Welcome back to this channel for practice problems for actuarial exams. My name is Krzysztof Ostaszewski. You can find information about me at smartyurl.it/Jedi. My advice on how to pass actuarial exams is at smartyurl.it/pass. This video channel is at smartyurl.it/pass actuarial exams. Here you can have information about online seminars and study manuals for exams P, FM, IFM, and LTAM that I offer. I direct the Actuarial program at Illinois State University. You can find information about it at smartyurl.it/actuary. If you would like to offer a tax-deductible donation to support our students, please go to smartyurl.it/help ISU Actuary. Here's a problem for today for exam P on probability. You are given that the joint probability density function of two random variables x and y is, where positive, 6x squared y for x between 0 and 1 and y between 0 and 1. Calculate the probability that absolute value of the difference between y and x is less than 1/2. And here's the solution. So we have this, that the probability that absolute value of y minus x is less than 1/2 is equal to the probability that y minus x is between negative 1/2 and 1/2. That's the probability that y is more than x minus 1/2 and y is less than x plus 1/2. So that's the probability that y is more than x minus 1/2 and less than x plus 1/2, just expressed directly together like that. As the density is only positive inside the unit square, the probability sought can be calculated as the integral of the joint density over the region indicated in the figure below, which is the region where this condition is satisfied. So here you have it. Note that we have the line where y equals x minus 1/2, the line where y equals x plus 1/2. The density is only positive inside the unit square indicated, and the region over which we need to take the integral of the joint density is indicated with dotted lines. The shape of the region where the condition is satisfied is somewhat irregular, and it is easier to calculate the probability of its complement, which is the integral over the two unmarked triangles. So the probability of the complement is the integral from 0 to 1/2, and then from x plus 1/2 to 1 of the joint density with respect to y first, and then with respect to x, so plus the integral from 1/2 to 1 of the integral from 0 to x minus 1/2 of the joint density dy dx. That's the integral from 0 to 1/2 of the integral from x plus 1/2 to 1, 6x squared y dy dx, plus 1/2, the integral from 1/2 to 1 of the integral from 0 to x minus 1/2, 6x squared y dy dx. And that's equal to the integral from 0 to 1/2 of 3x squared y squared, evaluated from y equal to x plus 1/2 to y equal 1 dx, plus integral from 1/2 to 1 of 3x squared y squared, evaluated from y equals 0 to y equal to x minus 1/2 dx. And that becomes the integral from 0 to 1/2 of 3x squared times 1 minus x plus 1 squared, or 1x plus 1/2 squared, with respect to x, plus the integral from 1/2 to 1 of 3x squared times x minus 1/2 quantity squared minus 0 dx. Now we note that 1 minus x plus 1/2 squared is equal to 1 minus x minus 1/2 times 1 plus x plus 1/2. Difference of squares is equal to, so a squared minus b squared is equal to a minus b times a plus b. I call this the Chechnya formula because when I was a kid in elementary school in 7th grade, I took part in the competition for kids in Poland in mathematics, and my teacher told me to memorize this formula, that a squared minus b squared is equal to a minus b times a plus b, because it could be on the test. So of course I memorized it, and I took second place, and it was great. And I got the prize. The prize was top 2 kids in each region. So I was a second in my region, were given a trip to the Soviet Union. You know, the dream, right? So anyway, and part of the trip was going to Chechnya. So if you memorize mathematical formula, maybe you'll get a free trip to Chechnya. Sorry, my dog heard the word Chechnya and started barking at me. But anyway, so this is equal to 1/2 minus x times 3/2 plus x. And that becomes 3/4 minus x squared. And x minus 1/2 squared minus 0, that's just x minus 1/2 squared. So it's x squared minus x plus 1/4. So that the probability that we want, actually the complement, probability of the complement of what we want, is the integral that we just set up. That's the integral from 0 to 1/2 of 9/4 x squared minus 3x cubed minus 3x to the 4th dx, plus the integral from 1/2 to 1 of 3x to the 4th minus 3x cubed plus 3/4 x squared, and that becomes 3/4 x cubed minus 3/4 x to the 4th minus 3/5 x to the 5th evaluated from 0 to 1/2, plus 3/5 x to the 5th minus 3/4 x to the 4th plus 1/4 x cubed evaluated from x equal to 1/2 to 1. And then we evaluate it, as you can see, plug in all the values, and after some calculation we get it to be 1/8. And of course the probability we're looking for is 1 minus the probability of that complement, so it's 1 minus 1/8, which is 7/8, so 0.875, and that's answer E. Please remember this is copyrighted material. The problem was created by me and the solution is mine. All rights reserved. Reproduction in whole or in part without express written permission from the author is strictly prohibited.